Thank you, Chris. We got the presentation going here, and what we're going to talk about today is really what we at EMR try to accomplish with any products that we bring to market. So instead of trying to do something that becomes a engineering feat where you have to know how to program, where you have to know how to use CODESYS or SCADA or any of the other fun buzzwords that everybody throws out there, what we try to create is really a appliance. Is this showing up good, Chris, or is it blocking? I don't know if I've got my share done properly.
Looks perfect on my screen.
Okay, good, perfect. So what this is, we do a lot with water, wastewater customers. And in that industry, you've got a lot of custom programming. You've got a lot of specifications that are written around specific hardware, which limit what the customers used CODESYS, and we'll talk about why we use CODESYS here shortly. But the same appliance, and we'll get into some actual demonstrations of the appliance, can control booster stations for maintaining pressure and assist tanks in maintaining tank levels in the systems, and then also for lift stations. So your water and your wastewater, all from one appliance. And what we tried to create here, and the main reason we use CODESYS, is we don't want them to program anything. We want them to pull up the WebVisu, built-in web server, and be able to do the complete configuration, including mapping of all their I/O signals. So that's a very powerful feature, because sometimes in water, wastewater, and in some industrial settings, you might lose an input or lose an output. Surge, something along those lines, hardware failure. And being able to go in and quickly map it to another output or another input allows the operator minimal downtime, and he doesn't have to pull out a programming laptop, have the right cables, understand programming at all to continue the process. So everything's done there. And then also with this, we're doing local trending and alarming, which we'll show from the WebVisu. And we're trying to help the operators out. So one of the things here is a smart UPS and smart breakers, so that before they go to the job site, before they go and see what has happened, they know what the power is, what breaker might have tripped, why it tripped, short or an overload, and they can reset it through their own SCADA system. And really the last part here, it's a hardware feature from our partner at Berghoff, but it allows the customer to back up and restore the entire CODESYS program, IP related, so any of the network settings, all from a USB stick. So this is the most powerful feature, because by having a USB stick sitting there, they can restore an entire project to a new appliance in a matter of minutes. So no longer do I have to take out, have the right program, have the latest version of the program. As long as they've backed up the program from the beginning to that USB stick, it's as simple as plugging and playing. So what do we got here with CODESYS? Some of the reasons we use CODESYS, some of the things we're doing with this smart controller. So running PIDs, basically bumpless transfer. We got up to 4 booster pumps and up to 6 well sites and 2 valves in the same system. What it allows is load balancing. You've got water hammer prevention, all the things you're going to expect when you're trying to build a pump, booster station, or even a lift station. And as we have deployed these, we've got somewhere around 75 of these deployed right now in the field. We keep adding features that customers come back and say, well, it'd be nice to know if this one ran longer today than it did yesterday, or if the flow rate is different over a time period. So all those are new features we keep adding. But for the most part, everything here was something that was doable with CODESYS right from the beginning, and allowed us to be hardware agnostic. Now, we did pick the best hardware out there for this application, and you'll see that on the next slide with the Berghoff PLC. But the very nice feature here is even if they want to change hardware in the future, all of our code will be reusable. So it allows us to have really our own appliance and our own software and not have to rely on a hardware vendor to continue making the same product. And we see that quite often where the hardware vendor either changes what they're doing, they remove a COM port, they remove a NIC so you don't have the network access that you wanted before, or change their IO mix on their controllers. Kevin, anything to add on this page?
Yeah, I was going to say I think the biggest benefits of CODESYS coupled with the hardware is that we don't have to be worried about communication protocols. Everything's embedded, it's integrated, it's our go-to for any solution.
No, it's a good point because other hardware vendors are going to have to add a communication card. They might have to add an Ethernet card or a Modbus TCP card, or they might not be able to do MQTT directly out of the product or OPC UA. And then OPC Pub Sub is our latest one that we're testing with these products to be to run these over a low bandwidth radio solutions. So here's a look at our hardware. So it's a little bit of an eye chart, but I think everybody here can hopefully understand what we're showing. So in the upper right, you've got your booster pumps. You've got a tank that we're filling. You don't have to have a tank. You could be boosting pressure directly from the water treatment plant. It really doesn't matter. But for those booster pumps, we're able to control them over Modbus. We've got 3 different flavors right now, and it's a product feature we'll discuss a little bit about, but we can control Danfoss, Yaskawa, and worldwide up to 4 of those. And basically we're setting set points and maintaining pressure for the system. And then you see the tank there, and you've got your pumps, your well pumps or valves filling that tank. Those are normally hardwired to outputs or inputs on the PLC. But we also, as we'll show, we've got some that we can run over Modbus. So in some situations, the wells are remote from the tank site. And in that situation, they're able to run a Modbus TCP over a standard radio connection and be able to control up to 3 wells for filling that tank. And then you see in the upper left there, the smart UPS and the smart breakers. So this is really what starts setting us apart from some of the other pump controllers on the market. They'll give you a lot of features and a lot of functions, but it's still the same old thing. When you get out there in the field, you still have to use a fluke meter. You still have to know what you're doing to be able to troubleshoot this. We've tried to make it easy so that before you drive to site, you know, do I have 120 volts coming in to my UPS? What is my battery usage? What's my discharge rate of my batteries? How long do I have before the batteries are going to go down? Also on the smart breakers, I've got the ability to monitor not only voltage, but current usage for each one of those breakers. So that's a very important feature because when you originally set this up and we go in and configure, we can set a set point to say breaker 2, which is for my analog inputs, it's only pulling at half an amp. So next month, if that's pulling an amp, something's changed. And now I can know that's a problem. That's an issue. If I'm getting bad signals from a flow meter, from a pressure transducer, from anything along those lines, I know it could be along that path for current. The other thing that's nice about this is if you have a short or an overload, we get notified immediately. So that in and of itself allows the operator to know, hey, it was a digital input that shorted, a digital output that shorted or overloaded, analog in or analog out. And basically each one of those is on its own breaker. That allows us also to be able to reset that remotely, that in the event of that failure, I can now go back and say, let me try to do a reset. Maybe it was a nuisance trip. I think everybody on this call knows there's no such thing as a nuisance trip. Something has happened, but it might save them a drive out to that remote site so that they do not have to worry, at least that night, to go out and correct something. Kevin, anything to add here?
No, I don't think so.
The nice part here too is the Berghoff controller. You can see here in the middle, it's got dual NICs. It's got enough Modbus ports, so two RS-45s, one RS-232, and a CAN bus port that we haven't used yet, but we are looking at some usage in the wastewater for some of that CAN bus. But it allows us now to segment. So internally to the panel, our Modbus is on one channel for our UPS, our smart breakers. And then we're also looking at vibration and temperature monitors on those, if the customer so desires, flow meters, whatever you might want. And then on the VFDs, because they're mission critical, we allow them to be on their own Modbus channel. And then that way we don't have to worry about something else going wrong on the Modbus to prevent us from controlling the booster pumps. Because in the end, maintaining pressure and maintaining tank level here is what the customer needs. So with any kind of catastrophic failure, we want to make sure we're still maintaining pressure in that system and keeping the tank full. So I am going to stop sharing that now, and we're going to dive into the actual test bench we've got set up. All right, so still seeing the screen good?
Yes, perfect.
All right, good. So this is, for you CODESYS guys out there, the actual web visu we're hosting from one of our appliances. What's unique is, from the operator standpoint, as long as he dials into the local IP address here with that web visu, he's able to get into the controller and from here do everything as far as setup is concerned. So the first thing I mentioned, which was nice, is being able to configure where these I/O signals are going. So for retrofits, you might have VFDs that are over Modbus. So you can see here with our drop downs in CODESYS, I can scroll down and pick Modbus and control over Modbus. Or I can pick any of the remote I/O modules I might have installed, or my actual PLC, which would be the base PLC appliance there in the field. So this allows me to map everything to do with that PLC, with that device. I also have all of my analog settings here. So for influent flow, effluent flow, whatever they might do, pH, most of the systems now are doing redundant pressure transducers and redundant level transducers. So those are coming in live to the system. So the customer operator knows, hey, I've got a discrepancy between my primary, my redundant, and I can change scaling. The nice thing here too is not only am I selecting where that I/O is mapped, this comes back to if we have one that burns up, we have one that goes bad, I'm able to now very quickly and very efficiently change where it's mapped. There's nothing to do with the program. All we're doing here is mapping hardware. Can also come in and change all of my set points, all of my alarming, and simulate. So we've got the simulation mode built into the product directly so that we can simulate and see what might be happening before putting this out in a real world environment. Same on our analog outputs. These are mostly used for chemical feeders. So we're mapping to the chemical feeders here, still scaling, and then showing the customer the actual milliamp output that they're getting from that PLC, that controller. So once we have our I/O mapped, then we go into our booster controller. Here's the main things the booster controller is looking at. So this is where we're maintaining pressure, maintaining flow, or maintaining a level from those booster pumps. Here we can now come in and set all of our alarming, and we can change the alarms here too to know, is it an info, a warning, or a critical alarm? And is it latched? So what latching means, for everybody that doesn't know, is once that alarm happens, someone has to acknowledge it before that pump will restart. If we don't latch it, critical means it will shut the pumps down, but once it comes back to an offset point, it will restart the pumps. This is very important also, because in a lot of cases, they might have an issue with their tanks. So in this particular customer that we're looking at here, if the tank gets too low, they can't run the booster pumps. So that means they want to shut the booster pumps down. If the tank is below 15, or if the tank is below 8 feet down here on our level, once it gets back up above 9, they'll let them run again. So you'll see a sawtooth. If they have trouble filling that tank, they still maintain pressure. The alarm resets itself, but it still protects the pumps. So you don't have to worry about a cavitation or your pumps running dry with this type of alarming and this type of system. And they still benefit from all the input and output mappings here. And each one of the pumps the same way. So with the Modbus, you have these signals automatically. Your run, your fault, HOA, handoff auto, and then any of your outputs and your scaling. So like for this one scaled 0 to 6,000, which would mean 0 to 60 hertz. But you can scale that any way you want because it allows the operator complete control of how the system's working. Under our station screen, this is where the actual fun happens. So you got a set point that you're trying to maintain. You got all 4 pumps, your on and off set points for those, and then also your PID and all your tuning involved for that PID. This allows them to really tighten up how quickly and how closely it maintains the set point. In a water wastewater system, usually a couple PSI doesn't matter. But if you're getting into some where you're filling or pressurizing tanks, they need to be tighter on the tuning parameters. And from here now, I can test and make sure it's working properly. The other thing this allows is staging on and staging off of pumps. So what we put into here, if a pump has run for right here, it's 120 seconds at 44 hertz, and it's below the set point, that means shut it down, let it go to sleep. It does not need to run. The pressure is okay. Same thing on and on. If it's above 58 hertz, which means it's running all out and it's not maintaining the pressure, after 15 seconds, what will it do? Start a second pump. So that second pump will now stage in and help maintain the pressure. The other nice feature here using the WebVisu is, so right now I've got 1 booster pump in this setting. So I'm going to go here and I'm going to turn on a second booster pump, and I'm going to make sure my pump controller knows it's enabled. And then once that's done, I now have a second booster pump right there on my visualization. So using the WebVisu, we're able to hide graphics. Everything is a template inside of here. Same with the fill cycle. So here's my tank. I got my on and off fill. I can go to my local well settings. I've got all my IO to map. I can go through the PLC right on board, remote IO, or if I want remote wells, here we are with our Modbus TCP connections. So from here, I can actually put in my Modbus TCP address and enable my comms to start and stop wells over Modbus. And in some of these systems, everything's configurable here. So you can see disabled. So in some of these systems, the remote well feeds in, but the chemical feed is at the tank site. So this allows you now to come here and set a PLC output to feed chemicals whenever this well is running. So the customer can configure completely what he wants in this system. So if we go in and we set a new local well, same thing, we could run a chemical pump off of it, map all our IO. Now I've got a new local well here also. And the system will stage those in and out as it needs to. Now we'll show the real fun part, which is our actual CODESYS program behind all this interesting. Well, come on, guy. Here we go. My internet connection is unstable, it's telling me. So the nice part about CODESYS, why this is so fun and so easy to use and why it was easier to create this appliance using it, is really here on the left-hand side. We've got our web pages, all of our templates. We've got our programs. We've got everything organized, easy to maintain, easy for Kevin to troubleshoot, and all of this. So I've got here pulled up my retained values, right? The really neat part here is once the customer configures exactly what he wants on this station, And out of those 75 we've got installed, they are all different. I mean, it's crazy that these water systems are so different, and how much effort has gone in to make this easy. But once he's done, over here in the little right, you can see save settings, right? So if everybody can see that, right now my timestamp on my file is 11:34. If I hit save settings, what now has happened is 1:14 is my timestamp. What have we just done? We've just configured a pump station, created a recipe for that pump station, and backed it up and saved it. Now, this can be offloaded from the PLC to that same USB stick so that when the customer restores, he's able to bring that station completely back up. Or if he does have one that is close to that station, he's able to restore that to start without having to go through and do a ton of the configuration like I just showed you. So that's the configurable side of it. The other part is really, how do you monitor, how do you support this? So through the same thing, we've got alarming. So the alarms are built in, and we're also using the alarming for operator monitoring. So what that means is if I come in here and I change my pressure set point here on the screen or over SCADA, this also is a Modbus remote. So from Modbus TCP, I can do all of this through a SCADA system. We've got it all mapped. So once I do something like that and change it, I'll go back here to my alarms and come to history. And you can see right there, normal pressure set point changed to 34. So we're also tracking what's going on. If they're starting, if they're stopping, if they're changing the handoff auto. You can see all the faults we're having right now because the PLC is trying to communicate with that Modbus drive that's not available out there. So all the tracking is built in, and all that's local. And that's a big point here, is they do not need anything else. We're also sending emails out on alarms from the system. So any of those alarms, they can get an email or a text message. And we're doing all the trending here too. So you've got your tank trend. Here you know if the wells are running, if the valves are open. And then we have anything with the pressure trending. So what the speed of the VFD is, what our pressure set point is, and what our PID output is. So that's important to know, because we want to know, is the PID tuning up and the drive's not following? Is it running too fast? What's actually happened there? I mentioned the smart breakers. So here you've got all your smart breaker outputs. You got your amps and your volts. And from here, I can turn them on and turn them off and reset them if there's a fault. And then from our smart UPS, basically the same type of thing. I don't have it tied in right now, but you'd have your 120 volts, you'd have your load, you'd have your batteries, and your temperature of those batteries from the same setup, from the same station. And then even to station IO, so your digital inputs, you can map everything here. So if I don't have an intrusion, it's just disabled. It doesn't matter. It won't look at it. And part of what the programming for this went into is, when you look at a local well, if you don't have an auto or you don't have a running signal, if it's disabled, the code itself knows I don't care to look for a running. It's just going to try to run it. If you add a running, what's going to happen? It's going to try to run it. And if it doesn't see a run feedback, it's going to fault and switch to the next one. So that also allows it to be very customizable in the field, because a lot of these are retrofits to existing stations. And when we get into the field, some of them do not have aux contacts wired up. They don't have anything but a go output. And we can make that happen by just simply remapping the IO. And that allows us to keep from getting into the program and having to get online with anything. And then every time they make a change or a setting, they go here and do save settings, and they can also load the settings from that recipe file. So we're doing that. And then we're using the recipes for a lot of this. We're also doing some flat files stored on the controller to maintain some of our retained and retentive memory also. User management. So we do allow operators to log in, log out, change settings, not change settings. I think that's our main show. The updates that we're trying to do on this. So one of the things that was a little difficult here is through the product tree, it's not easy to add communication drivers. And I did see in the talk earlier, thanks, Chris, for all those, that they are looking at allowing through runtime to add communication and add different, basically, drivers inside of there. So some of our updates will be direct interface to some of the alarming systems. So writing the API inside, or the gets and the puts inside of our program, so we don't have to go through email servers for our alarming, and using the Modbus function block. Most of the water wastewater is going to be Modbus protocol, either RTU or TCP. But writing that and using that so that we do not have to rely on the product tree, which is what's limiting us right now on some of the things we're trying to do. Because we have to disable, enable this through the WebVisU at runtime, because we don't want to have to go in here and do a ton of work inside the actual program before we deploy on site. So that is our smart pump controller. Let me see here. Any questions, Kevin? Anything else you want to share with this?
No, I think we pretty well covered it.
All right. So any other questions you have? Here's our share. So what I was saying, right? So we're now working on the pushover API, advanced alarm configurations. Yeah, I'm almost done, Chris. So on the advanced alarm configurations, what we're going to do is all the alarms right now are going out over email. We want to be able to let the operators decide what actually gets sent out over the API, over the emails. The WebVisU configuration, MQTT, we have MQTT working right now, and it's sending to our cloud database, our cloud server. Very simple and easy. But that's another one where we need more configuration so the operators can decide what they want to see. Because we're not sending everything up there right now. It's just too much inside of this. And then the last is being able to upload the recipes directly from the WebVisU. So opening a file window so that we can suck in the recipe directly from our Chrome or our web interface. And then the multi-vendors on the Modbus, we want you to be able to drop down and say, I've got an ABB drive on VFD1. I've got a Yaskawa on VFD2, and mix and match however you want. Because with the Modbus function block, you're able to do that at runtime. So we can change all of those, what it's reading to, what it's writing to, through runtime once we get that implemented. So here's our contact. Any questions, reach out to me or Kevin. Chris, appreciate this as always. It's always fun. Hopefully this was technical enough for everybody, because we did get deep into this thing. Kevin and I were discussing it. So let us know.